All right, good evening, College Trig. Today we're going to do our notes on 6.5 double angles. This is going to be part A, and tomorrow we'll go ahead and do our half angles formulas, part B. All right, so our double angle formulas are on your yellow sheet. Notice that we have only one sine equation and we have three cosine equations. And these are just taken from our angle sum because we can just substitute and call sine of alpha and just make the other one alpha as well, and you can see that this is what you're going to get if they're both the same. In other words, sine of 2 alpha. So you can derive those. For cosine, you can do the same thing, and substituting in different Pythagorean trig identities, you can get the other two. So notice we have three cosine double angle formulas, and we have one sine double angle formulas, all on your yellow sheets. From that, we can also get our tangent double angle formula, also appears on your yellow sheet, and that just, again, comes from that's going to come again from our sine and cosine double angle formulas. For here, what we're going to also get is our power reducing formulas. So we can take our double angle formula, and we have cosine of 2 theta, we can write as 1 minus 2 squared theta. If we rearrange those and solve for our sine squared theta, we can come down and get to a power reduced. So no longer do we have cosine or sine to the second power. This will be really helpful when we get into calculus for this. Also, similar idea can be used for a power reducing one for cosine, so that we can solve this for cosine squared theta. Add the 1 to both sides, divide by 2, and we can see we can get our power reducing for cosine, which also appears on your yellow sheet and will be really nice for use in calculus. So from here, let's look at this is the tangent power reducing one using the ones from sine and cosine, and we can see that sine of 2 theta, we have 1 minus 2 cosine theta over 2, and we multiply by the reciprocals, and our 2's cancel out, and we're left with this, our formula for tangent squared theta there. All right, so that's where those formulas are coming from. Here's a problem that we'll be doing in class. So again, sine of theta is equal to 5 over 13. Theta is between pi over 2 and pi, which is really just telling us that we are a quadrant 2 angle. We already know that sine is positive, so it must be a quadrant 1 or 2 angle. Because this condition is met, we know we have to be down here in quadrant 2. So if we want to find the exact values of sine of 2 theta and cosine of 2 theta, I need to make sure I know my sine and cosines of my angle theta here. So if I draw my picture and draw my triangle, and I see I have 5 and 13, I can use my Pythagorean identity or my Pythagorean theorem to find my alternate side. So now that I have that, I can rewrite, and I can write all these. So I know that sine of theta is equal to 5 over 13, which was given. And then I also know that my cosine of theta is equal to negative 12 over 13. And it's got to be negative because it's a quadrant 2 angle. So now using my formulas. So sine of 2 theta is going to be equal to 2 times sine of theta times cosine of theta. Now, all I have to do is do my arithmetic. I get 10, negative 120 over 169. And there I have my solution for sine of 2 theta. My next is going to be calculating my cosine of 2 theta. And I can choose to use any one of my 3 cosines. I'm going to go ahead and use the first one on my yellow sheet. So I have cosine of theta, which is negative 12 over 13, minus, and this is squared, minus sine of theta squared. So first I'm going to square them. I'm going to get 144 over 169 minus, squaring this, I get 25 over 169. Already have my common denominator, is nice. And I get 144 minus 25, so I'm going to get 119. Notice that both of our answers are less than 1 or greater than negative 1, because I know my range of my sine functions need to be that. My denominator always has to be larger. So that's how I'm going to use the formulas there. All right, our next one, our identities, our favorite. So let's go ahead and look at this one. All right, so the first thing I'm going to do is, again, it's an identity, so I'm just going to try and work from one side and make it look like the other side. So I'm going to work on the right side first. I have the sum of cubes here. So in my book, I can find the sum of cubes, and we did this in college algebra, but we should have that a cubed plus x cubed plus a cubed. The sum of cubes is equal to x squared minus ax plus a squared times x minus a. So now using sine and cosine there, I can see that this is going to be sine squared minus cosine sine plus cosine squared, just leaving my thetas out for just simplicity. And then I have sine minus cosine all over sine of theta plus cosine of theta. So these are actually, this is a plus and this is a plus. So when we look at here, we can see that these two factors are similar. So I can reduce this, because these are products here. It's not addition and subtraction. This will reduce to 1. So then I'm left with, this is equal to sine squared minus cosine. And I'm going to kind of rearrange these here because I see a sine squared and a cosine squared. So I see sine squared plus cosine squared minus cosine sine. Well, Pythagorean identity, one of our most basic identities, that is 1 minus cosine sine. So I'm kind of stuck there. So I'm going to look at my left side here and see if I can have it meet in the middle somewhere. So I'm still just working on one side, and I can use my double angle formula here for sine of 2 theta, and I can see that this is going to be 1 minus 1/2, and sine of 2 theta is 2 times sine cosine of theta. So without distributing that 1/2 across, I see that I get 1 minus sine cosine, which is what I have over here. So what I can do is I can just kind of rearrange these, and I can finish this off on the right side. So I can see, all right, the next step here, if I just write this and put a 1 minus 1/2 times 2 sine, and I'm going to keep my cosine sine the same. And then now that I have that, I can say that it's equal to 2 cosine sine. I can say that's equal to 1 minus 1/2. That comes from my double angle. So it is sine of 2 theta, which is exactly what I wanted to have at the end to establish that identity. So there, I'm done. All right, that's our notes for tonight. I'll see you in class tomorrow.